This is problem 1 on practice exam 7 of chapter 1 in the book Problem Solving with Differential and Integral Calculus. We have a goat tethered to the corner of a large square field of grass. The length of the tether is L, and that's less than the side of the square field of grass. So the area that the grass can graze is pi L squared, which is a circle, divided by 4, because it's a square field and the goat is in the corner. We need a good diagram to see what's going on here. So here's the goat. Here's the square field of grass, and there's the tether, length L, and the goat can eat all of this. The goat doesn't have access to this grass because of the tether. Derive the difference equation that relates an increase in the grazing area, delta A, to the original length of the tether, L, and an increase in the length of the tether, delta L. So if we have a tether of length L, and we add delta L to that tether, what's delta A? How much more area can the goat eat? Let's start with that one. Then we'll do B and C later. Here's the difference equation. We change L by delta L, and A responds by changing by delta A. So we can FOIL out the left-hand side. We have pi over 4 L squared, and we have an A. Those will cancel, and we just get delta A. There's the difference equation. On to part B. Use the normal equation to calculate the grazing area where the goat has access for a 20-foot tether, and then 20 feet 3 inches. So we're adding 3 inches, and we can subtract the area to get the difference. So there's the normal equation. We can stick in 20 feet, and the goat has about 314.16 square feet of grass he can eat. Now we're going to stick in 20 feet 3 inches, which is 20.25, right? A quarter of an inch. Now the goat has access to 322 feet, and we can subtract them to get about 8 square feet, 7.9 square feet more if you add 3 inches to the tether when the original length is 20 feet. Part C asks us to use the difference equation to check our answer. We should get about the same thing, 7.9 feet. So there's the difference equation, and since we didn't throw out the nonlinear term, it should be exact. So we have an L of 20 feet and a delta L of 0.25. We stick those numbers in, punch the buttons on the calculator. We can see the relative size of the linear term and the nonlinear term. 7.903 square feet. Exactly the same as we expected. And we can draw it. Here it is right there. 20 feet. The width of that thing is 3 inches. And there's the change in the area, which is a little bit less than 8 square feet.